Alright, so today we're going to look at section 6.2, which is, again, an application of integration. We're going to look at the area between curves. But remember, one of our fundamental ideas in calculus is that if I have a function and I move from A to B, and I want this area, then that area is the integral from A to B of f of x dx. So nothing real tricky there. So this area in here is the antiderivative evaluated from A to B. Remember that if the function is below the x-axis, this is going to get you a negative value. So if I ask for area, we need to make it positive. So for example, if I ask for this area, so this is cosine x, and suppose that I said, what is all of this area here together? Right? And so this goes, so this is, remember, when is cosine x 0? Cosine x is 0 at multiples of pi over 2. So this is actually pi over 2, and this is 3 pi over 2. And this is minus pi over 2, and this is minus 3 pi over 2. So I can't just integrate from negative 3 pi over 2 to 3 pi over 2 because I'll have a negative and a negative area and then a positive area. I actually need to integrate each thing separately. So I need to integrate from negative 3 pi over 2 to negative pi over 2 of the function cosine x dx. And then I need to add the other portions as well. Now, each of these in this particular case is going to be the same thing, so you could have just evaluated one of them and multiplied by 3. But in general, you've got to be careful about what's plus and minus as far as calculating area. What if I have this question? This is our function e to the x, and this is the function, let's say, negative x squared, and I want to know this area. That's my goal, to get that area. The area between these curves, between 1 and 2. Now we can do a couple of things here, right? So I could actually just take the positive, this area that's above the x-axis, and I could just say, well, this is just that first area is just the integral from 1 to 2 of e to the x. Area under e to the x between 1 and 2. The second area, I could integrate negative x squared from 1 to 2 as well, but that's going to be a negative number because it's below the x-axis. So if I have a region that's below the x-axis, the antiderivative is going to be negative. But so if I actually want the area, I need to make that negative. But remember how these things work. This is just the integral from 1 to 2 of e to the x minus, I'm going to keep all my signs here for just a minute, minus negative x squared dx, which certainly does make plus, but for now, let's notice what we've got. We've got a subtraction, top function, e to the x, minus bottom function, negative e to the x, even though one was above the x-axis and one was below the x-axis. So and this is actually in general true. If I want to know the area between any two curves, no matter where they are, whether they're both above or they're both below or one's above and one's below. We're just going to integrate top function minus bottom function. And I should say that right now, we're actually just looking at setting up the integrals. We'll spend some time evaluating them as well. These are fairly straightforward ones to evaluate, and I just want to focus on setting up the integral that gets us what we want to get. So let's look at another one. So here's x cubed. Oops, make this picture better. Here's x cubed, and here's x. Let's find this area. All right, so we need to integrate top function minus bottom function, but there's a couple of things going on in this problem. I'm not told explicitly where those values are. So this is 0, right? They meet at the origin, that's fine. But what is this value? What is that x value? Well, I don't know yet. What is that x value? Well, again, I don't know yet. So if I need to figure out where these two functions meet, I'm asking when is x cubed equal to x? So when I'm looking for the intersection of these two functions. Well, that's x cubed minus x is 0, which is x times x squared minus 1 is 0, which is x equals 0. But this, if x squared minus 1 is 0, that's x minus 1x plus 1 equals 0, which says that x is 1 or x is negative 1. So I've actually got negative 1 for this x, 0 for this x, positive 1 for that x. So now we have to set up two different integrals to find the area, because over here, x cubed is on top, and over here, x is on top. So I need to integrate top minus bottom, which is x cubed minus x on this region. That's from minus 1 to 0. And then I also need to integrate top minus bottom, which now is x minus x cubed from on this region, which is from 0 to 1. Okay, now, sometimes we need to turn our heads and look at things in the other direction, so integrating with respect to y instead. And so let's just remember how that's gonna work. So what if I had something that was like this? Suppose that I had a function which is, let's just say that this is x squared, and let's say that this is 2x squared, and I want to know this area. That's what I would like to know. Now you could do this by integrating with respect to x. You could move along the x-axis, but you'd have to do a lot of stuff. You need to figure out what that x value is, because you'd have to break this up into a lot of different regions if you wanted to move along the x-axis. Because over here we have top function minus bottom function, that's fine. Over here, well, the top function isn't either of them. It's actually 2. And so it would be y equals 2, and then minus this bottom function. So you'd have to actually break that up into two different pieces, figure out what that x value is at the point that this happens. It's actually much easier in this situation to look by moving along the y-axis instead. So we're going to integrate along y rather than integrating on x. Because if I integrate in the y direction, I have a top function minus a bottom function that's the same across the entire region. Right, so if I look in this direction, now I have top, I have bottom, and the top and the bottom function doesn't change at all as I go along the entire y range. And so this was y equals 2x squared, and this was y equals x squared. But if I'm integrating with respect to y instead, well, my y's clearly are going to go from 0 to 2. All right, so this is y equals 0 to y equals 2. But remember, when I integrated the first time, I had y equals e to the x, and I put e to the x in here because my variable has to be y. It was x originally, but now my variable has to be y. So I can't put x squared top function minus 2x squared. That doesn't make sense because my variable now is y rather than x. So what I have to do is take my y equals x squared and transfer it over to figure out what the y is. And so I'm going to do that by saying x is equal to the square root of y. So now I have the y version instead of the x version. And so if y is equal to 2x squared, then x is equal to square root of y over 2. Which means instead of putting my x's in here, we'll put our y's in here, but the top function corresponds to y equals x squared, which was this one, x equals square root of y. The bottom function is the second, which was square root of y over 2. And this is the integral in terms of y that will give the area that's in question. Okay, so that's the basics of 6.2. And see you next time.